Welcome, pre-algebra students, to our video on scientific notation. And I know this is probably review for most of you, so if you feel that you want to pause the video at different points and just copy the problems and try them yourself and then watch the video to watch the answers, that's awesome. I love it. Go for it. If you know that this is something with which you struggle, then take your time and listen and watch, and I'll do my best to explain it to you as well as I can. I love this Einstein picture because he looks so happy. He never looked happy in pictures. But anyway, scientific notation, how to write very large or very small numbers efficiently. But first of all, writing a large or a small number using the product of a decimal and a power of 10. So product, remember, means multiplication. It's one of the only places you'll still see an X, but sometimes you'll see a dot for the multiplication with scientific notation. We use it in scientific calculations, and we'll give you some examples of places where in just a minute. So when you have a scientific notation number, you have a decimal value that is between 1 and 99.99, and it could have more digits after that. But it's between 1, it's got to be bigger than 1, okay, or equal to 1, and smaller than 10. Can't be 2 digits before that decimal point, only 1 digit. A multiplication symbol of some kind, like we already pointed out, so either a dot or an X. And then the number 10 with a power. And that exponent can be positive or negative. And we're going to talk about the difference as we go through. All right, why? Why? We always want to know, why do I have to know this? Well, because some numbers are just too large or way too small to express with standard notation. Standard notation is the regular way that you write numbers in math. Now, it's underlined because it's vocabulary. Scientific notation is also vocabulary. You have to know both. Okay, you have to know both. Let's start with really tiny numbers. Like these values over here, right here, the mass of a proton, the mass of a neutron, or the mass of an electron, which is really, really small. So let me just write out the mass of a proton without using scientific notation. Are you ready? (15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, and you notice I couldn't even get it on one line. That's the mass of a proton. So that's not something I can even type into a calculator. I mean, the calculators you use in your class can only type so many digits at a time on the screen. So that's an example of why we have scientific notation. Your calculator has a very easy way of displaying this. And we will talk about that in class when we use calculators. Now over here, this guy's name is Avogadro. For my folks who like these interesting asides, Avogadro. This is Avogadro's constant right here. See this number right here? In 1 kilogram of water, you have this many molecules. It's called a mole. Okay, a mole. Not like the animal, but it's a number. It's a specific number, and it's the number of molecules of something in 1 kilogram of that substance. And I'm really, really hoping that I'm saying all of that correctly because it's been a while since I've thought about chemistry. That is high school chemistry. The reason I bring it up, though, is that when you get to high school chemistry and you have to express this number, 6.022 times 10 to the 23rd, it's a lot easier than writing it without the scientific notation. So again, let me go ahead and write this without scientific notation. 6, 0, 2, 2, that's 3. 1, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Go back, comma, 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 and comma, and comma. That's a 0. Don't think it's a 6, or a 2, comma, and comma. Wow, that's a huge number. So again, in scientific calculation, especially in chemistry and in physics, you need to be able to express these teeny, teeny, tiny numbers and these gigantic numbers, and you can't do it in standard notation. It's just not functional. All right? So how do we do this whole scientific notation thing? Converting a number from standard to scientific notation. This is the basics of what we're doing when we change a number from standard to scientific notation. You're going to place a decimal point after the first non-zero digit in the number. That means literally what it says, not a 0. So the first digit that's not a 0, put the decimal point after that. Count the number of decimal places you had to move the decimal point to get there. That's second. And third, write the number as a product of the decimal and a power of 10 using the number of decimal places moved as the exponent. For numbers that are larger than 1, the exponent is going to be positive. For numbers that are smaller than 1, the exponent will be negative. Now, if you've now listened to what I said, read through this, and copied it down, and you're still feeling apprehensive, nervous about what you're doing in the next step here, I want you to relax. If you learned this last year, just go with what you know, and hopefully that you've remembered how to do it. And if not, listen, pay attention, everything's going to be fine, I promise. So let's try some. Write each number in scientific notation. So the first thing I'm going to ask you to do with a problem like this is to write the number separately from where it's already written. Put in your decimal point after the first non-zero digit, which is after that 2, which means my decimal point is going to go right here. So the number part of my scientific notation for this is 2.0 times 10. Now look at how many places you had to move that decimal point from the original position in the number to that new position. Now, it helps if we remember that a whole number has a decimal point all the way at the right-hand side. If you don't see the decimal point in a whole number, it's all the way at the end of it. How many places do we move? 1, 2, 3. So we put a positive 3 exponent. So 2.0 times 10 to the third power is the same thing as 2,000. How about the next one? 680,000. Decimal point goes right here. 6.8 is my decimal portion of my number. And now we figure out how many places we moved it. We moved it 1, 2, 3, 4, 5. So 6.8 times 10 to the fifth power is the same thing as 680,000. Now real quick, let's compare these two numbers. In this one, the 3 was the same as the number of zeros that we saw here. But in this one, there were only 4 zeros. So this is not a number of zeros. So do not consider this number of zeros. It's number of decimal places. 5 decimal places, 3 decimal places. All right. Try the next two. My suggestion is definitely to go ahead and pause it and try them. But I will go ahead and continue on. All right, right here, we're going to put our decimal point. Oh, that looks like a 4. We're going to put our, I have an extra 0. Sorry about that. Put our decimal point. Where exactly? Well, we're going to put it right here between the 5 and the 9. So my numerical portion, my factor portion of the scientific notation is 5.94 times 10 to the, count them, 1, 2, 3, 4, 5, 6, and 7. And finally, this last one, let's use my pink, 62. Well, where does that decimal point go? After the first non-zero digit. So 6.2 times 10 to the, well, we only moved it one place, so the first power. Now that looks really goofy, but let's stop and think about what they all mean, okay? If you're asked to express something in scientific notation, we have to do it, even if it doesn't look like a number we're supposed to express in scientific notation. Let's think about what this means. This right here means 6.2 times 10 to the first power, which is 10. Multiplying by 10 is moving a decimal point once. So clearly the two numbers are equal. It's just that we use the scientific notation in varying places in science and in math, so we have to be able to write our numbers in scientific notation. Let's try going the other way. Again, if you look up here at the right, just like the previous slide, we're sticking to numbers that are bigger than 1. Okay, numbers that are bigger than 1. Positive exponents are for numbers that are bigger than 1. So now we're going from scientific to standard. So we've got to go backwards from what we learned how to do earlier. So what we're going to do is we're going to write the decimal number, and we're going to put in the decimal point where it is now, right here, so 3 and the decimal point after, and then we're going to go ahead and make our little egg carton, 1, 2, 3, 4, 5. I'm moving my decimal point the number of times my exponent tells me to move it. And I'm going to fill in my little egg carton with eggs, also known as zeros. Now note, your decimal point is not after the 3 anymore. It's after that last 0. So my new number is 300,000. 300,000. So 3 times 10 to the fifth power, 300,000. Same idea. Except this time, our 7 takes up one of our decimal places. 1, 2, 3, 4, 5, 6, 7, 8. Zeros in all the little egg carton spots. And we have 1, 7, 1, 2, 3, 4, 5, 6, 7 zeros. Put your commas in. It's 170 million. It's 170 million. Okay? Pause it. Try the next two. See how you do. I'm going to go ahead and power through and keep it going. 8.92, moving my decimal point 1, 2, 3 places, adding a 0 there. It's 8,920. No commas necessary. 9.512, moving my decimal point 2 places, 1, 2. It's 951.2. Now, why did they have that number in scientific notation? Well, we'll never know. But that's the basics of how to switch it from scientific to standard. Let's try some where the numbers are smaller than 1. Think about what those negative powers of 10 did. Remember that from class and then also from the video? Remember, 10 to the negative 1 is 1 over 10 to the positive 1. So your negative exponent is giving you a decimal or a fraction. All right, so continuing with the same directions we had before. Put your decimal point after the first non-zero digit. So in this case, it's 3 point, and we don't have anything to put after it. So you can put 3.0, or you can just leave it a 3. Times 10 to the what number? 1, 2, 3, 4 places we had to move it. So the exponent is a negative 4. Is a negative 4. So 3.0 times 10 to the negative 4 is our number that gives us 3 10,000ths. Let's think about that real quick before we continue. 3 times 10 to the negative 4 is 1 over 10,000, or 0.1234 decimal places. And if I was to multiply that, I do indeed get this value right here. Okay, next one. Decimal point after that first 2. So 2.24 right here times 10 to what power? 1, 2, 3, 4, 5, 6. So it's negative 6. Now I want you to try to remember that when your exponent is negative, the value of this whole number is smaller than 1. And that's an easy way to remember whether you're supposed to do a negative or a positive exponent. I want you to pause it. I want you to try the last 2 without me. Let's see how we do, because I'm going to keep powering through and do the math. Decimal point goes after the 8. 8.11 times 10 to the 1, 2, negative 2. Last one of these on this slide. Decimal point goes after the first 1. So decimal part of the scientific notation, 1.15. How many places moved? 1, 2, 3, 4, 5, 6, 7, 8, 9. So times 10 to the negative 9. Notice there's always the 3 parts to our scientific notation value, like we said in the beginning. Decimal, times, and a power of 10. A decimal, multiplication sign, and a power of 10. So 10 with an exponent. All right, last slide is going from scientific back to standard. Let's try it. So we did this before with our values bigger than 1. Now we're doing it with our values that are smaller than 1. And this should still say m times 10 to the negative n, because we are still dealing with our numbers that are smaller than 1. So again, take your number. Okay, I already violated my own rule. Take your number. This time, instead of writing it close, write it further over. Put in your decimal point where it is now and start moving. This time, because my exponents are negative, I know my number has to be smaller than 1. So I have to be moving my decimal point to the left. 1, 2, 3, 4, 5. There's my new decimal point. Fill in the empty spaces with zeros and then rewrite the answer. Please do not give me an egg carton answer. That's the work. This is my answer, 0.00008. Okay, next one. Same idea, write your number. Make your egg carton, 8 spaces this time. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I covered up my exponent. Fill in your egg carton and rewrite the number one last time as your answer. 0.1, 2, 3, 4, 5, 6, 7 zeros, 9, and 7. That has the same value as 9.7 times 10 to the negative 8th power. Last 2. Let's use this nice orange color. Again, pause it if you've gotten the hang of it and try them. Write your number. Make your egg carton with your exponent. New decimal place. Write your number one more time, 0.00312. A nice strong decimal point right there. And then the last one on this page, we'll do it in blue. Write your number. Move your decimal point up 1 place. 0.221. And there's our scientific notation value, or our standard form or standard notation value for that last scientific notation number. Plenty of practice with this on IXL. If you know you've got it down, then just relax. You know you'll be just fine for your quiz on Friday. I will see you guys in class.